A pelton wheel has a mean bucket speed of 10 meters per second with a jet of water flowing at a rate of 700 liters per second under a head of 30 meters. The bucket of deflection of jet through an angle of 160. Calculate the power given by water to the turbine and the hydraulic efficiency of the turbine. Calculate the coefficient of the velocity as 0.98. Now, write the given data. Uniform speed u equals to u1 equal to u2, which is equal to 10 meters per second, because this is the only speed which was given. Next, discharge. Capital Q equal to 700 liters per second. This was also given in the mentioned in the question. Angle of deflection alpha, which is equals to 160 degrees. So phi equal to 180 minus alpha. So alpha equal to 160 as it was given in the question. Substitute 180 minus 160, which is equals to 5, which is equals to 20 degrees. Remember, 1 minute equals to 60 seconds, 1 meter equals to 100 centimeters, which means 1 centimeter equal to 10 millimeters, so which is equals to 1000 millimeters. So in this way we have to come to a conclusion how much the speed of the runner will be in centimeters and millimeters. So thereby phi equals to 180 minus alpha, which is equals to 180 minus 160, phi equal to 20 degrees. Coefficient of velocity CV, which is equals to 0.98, sometimes 0.97 and sometimes 1.0. If majority it was given, it will be as 0.98. So take as 0.98 as CV value if the CV coefficient of velocity value was not given. The velocity of jet formula V1 equals to CV root of 2GH. So G is equals to acceleration due to gravity, H is equals to head. CV equal to coefficient of velocity, as I said you earlier. So V1 velocity 1 equals to CV into root of 2GH. Substituting, we get around 23.77 meters per second. So 0.98 root of 2 of 9.81 into 30. So head H is equals to 30. It was given in the question. G is equals to acceleration due to gravity 9.81, and 2 is in the formula. Root of 2GH equals to root of 588.6, which further equals to 24.2. That means root of 588.6 equals to 24.2 into 0.98, which will be equal to 23.77 meters per second. So this is the V1, which is equals to velocity. From outlet triangle, VW1 equal to V1, so thereby VW1 equal to 23.77 as well. Next, we have to find out the VW2 value, which further equals to, so VW2 equals to VR2 cos phi minus U2. Now finding about the VR2, V1 minus U1. V1 equals to velocity 1 and U1, which is equals to uniform speed. As I said you earlier, U1 equals to U2 equals to U, which is equals to 10 meters per second. V1 equals to the velocity of the jet. Now we have to find out VR2 first. VR2 equals to V1 minus U1, which is equals to 23.77, which we calculated earlier, minus 10.00, which was given in the question, which is equal to 13.77 meters per second. So thereby the final VR2 is equal to 13.77 meters per second. If we have to calculate the VW2, velocity of the water in the second end, which will be equal to VR2 cos phi minus U2. we had calculated about 13.77 cos 5. So 5 value equals to 20 degrees. So 20 or 10, it will be good mentioned in the question itself. So substitute the question, the value of the question here. So cos of 20 minus 10.00. So 13.77 into cos 20, which is equals to 12.8 minus 10.0. So thereby cos 20 we have to substitute here, which will be equals to, we have to calculate the cos 20 value into 13.77 minus 10.00. which will be equals to VW2 equals to 2.94 meters per second. Velocity of the wheel, if we have to find out. Now mentioning about the VW1 equals to velocity of the water in pipe 1, velocity of the water in pipe 2, V1 equal to velocity of the jet. So velocity of the wheel, U equals to, small u equals to 5 root of 2gh, root of 2 into g is equals to 9.818 acceleration due to gravity. The value of the acceleration due to gravity is 9.81 and h is equals to 30. By substituting we get 38.85 meters per second. Velocity of the bucket equals to u equals to 0.45 into v1. So 0.45 into v1 equal to 23.77. By substituting we get 10.69 meters per second. This is the inlet triangle diagram, as you can see above the screen. So this is the inlet of the screen diagram. U2, VW2, VF2, VR2. So angle equal to 165 degrees. Now later I will explain you better about this by drawing a neat sketch about this. In some of the questions it will be mentioned capital H equals to net head or effective head, Hg equals to gross head, Hf equals to friction head. So this is the way of representing all the heads. So Hf equal to friction head, Hg equals to gross head, and capital H equals to net head or effective head. Now Hg minus Hf, for example, in some of the cases it will be given the Hg value. Let us take Hg equals to 40, then Hf equals to 40 by 3. If Hg equals to 45, Hf equals to 45 by 3. That means friction head, which will be equals to 1/3 part of the gross head. So 45 divided by 3, 40 divided by 3. If Hg equals to 500, Hf equals to Hg by 3. So thereby Hg equals to 500 divided by 3, which ultimately equals to 166. So Hf equals to 166.66. Now capital H equals to 500 minus 166.66 value. 500 minus 166 equals to 333. We get around 97169.08 Newton meter per second, which is equals to 97169.08 Newton meter per second. Now, so this is the force exerted by the jet on the bucket. Okay, the values, the calculated values might differ slightly. Calculation differs, so that's not a problem. It will be very minute, like 971.68, 69, 72. So the values will be differs very slightly, so that's negligible. This is value of the bucket, which is force exerted by the bucket on the force exerted by jet on the bucket. Next, power delivered equals to, this is Fx, right? F suffix x. We got around 97169.08 divided by 1000. So by dividing by 1000, which is equals to 971.699 kilowatts. into 1000, we got 971.699 kilowatts. So this is approximately equal to 972 kilowatts. Work done by jet on the runner formula equals to rho AB VW1 plus VW2 into U. Rho equal to density, which is equals to 997 kg per meter cube. Density equal to density of the water. Rho equal to density of the water. So that particular density is 997 kg per meter cube. A equal to pi before d square, V equal to velocity. VW1 equals to velocity of the water 1. VW2 equal to velocity of the water 2. U equals to uniform speed. Next, we have to resubstitute that. So rho into Q into VW1 plus VW2 into U. So rho into Q. Rho equal to 1000 as it is density of the water. Okay, 997 as I said earlier. Density of the water is 997 kg per meter cube, approximately 1000. So Q equal to 40. VW1 equals to 23.77 and VW2 equal to 2.94. So how we got VW2? VW2 equals to VR2 cos phi minus U2. So thereby by substituting we get 2.94. So by this is the VW2 value. So VW2 equal to 2.94. U value was given as 10, and by all substituting this, so 4000 into something, we get around 1165.624.4 Newton meter per second. So this is the value work done by jet on the runner. This is the jet ratio, small m, which is represented by capital D by small d. Capital D equal to 0.764, small d equal to 1 by 6 of it. So 1 by 6 into 0.764, which is equal to 0.1268, which is equal to approximately equal to 6.02. That means 6 number of jets. Here, so here 6 number of jets. Power given by water for runner, which is equals to work done per second by 1000 equals to 1165.624.4 and divided by 1000 equals to divided by 1000. So thereby 1165.624 kilowatts. As it is kgs, we have to divide by 1000. We get around 3 digits. Before 3 digits, so here this is last digit is 4, right? So before 3, from here to 3, 1, 2, 3. So before 6 we get dot 1165.624 kilowatts. Finding about the hydraulic efficiency. For every efficiency there will be 3 efficiencies for every turbine: hydraulic efficiency, mechanical and overall. Overall efficiency is the product of mechanical and hydraulic efficiencies. So this is one of it, this hydraulic efficiency. So eta H equal to hydraulic efficiency, eta M equal to mechanical efficiency, eta naught equal to overall efficiency. So eta naught we get by multiplying the eta H into eta M. So eta H value, let us come to the point. So hydraulic efficiency equals to eta H, which is equals to 2 into VW1 plus VW2 into U. So let me describe about this. VW1 equals to velocity of the water 1, VW2 equals to velocity of the water 2, U equal to uniform speed, divided by V1 square, V1 equal to velocity. 2 into 23.77 plus 2.94 divided by V1 square, so 23.77 whole square. By substitution, by calculating we get 534. So 2 into 23.77 plus 2.94 into 10, which is equals to 534.2 divided by something we get around 23.77 equals to 565.01. We get around 94.54% of hydraulic efficiency. This is the formula for finding out the hydraulic efficiency. That is how we find out this, and hydraulic efficiency is 94.57. Up to now we are clear about eta H equals to hydraulic efficiency, which is equals to 94.54. Eta M equal to SP by power to runner. Power to runner equals to 9171699. SP equal to 91772. So into 1000 cancels out, divided by which equals to 94.99. So we get around 0.9499, which is equals to 94.99 in percentage. Overall efficiency equal to product of the mechanical and hydraulic efficiencies, which is equals to 0.94 into 0.94, which is equals to eta naught equal to 0.88. So eta naught equal to 88. So 0.88, which is equal to 88% of the overall efficiency. So thereby the efficiency of the overall efficiency of the turbine is 88%. Hydraulic efficiency is about 94.54. Eta M is equals to 94.99. So this is overall efficiency. We have taken overall efficiency value as okay. Coming again. Eta H equals to 94.54. Eta M equal to 94.99. Eta naught equal to 88.36.